Hi folks, this is Stan Forster. We're at the midpoint of the week. Okay, so everybody should have gotten their the written problem assignment in. And so I thought I'd give a little feedback just to start here. And I'm just going to go through the blue ray. The red ray, and pretty much everybody got it. Refracts off the first surface, travels through the prism, refracts at the second surface, and passes out of the prism. Okay, let's take a look at what happens with the blue ray. Okay, here's Snell's equation. Okay, Snell's law, excuse me. Okay, the refraction index of air, n sub air times sine 30 degrees, okay, equals the index of refraction of the material in the prism times the refracted angle in the prism. This is our one unknown. That refracted angle is our one unknown. You might be asking, where did 30 degrees come from? Well, if this is horizontal and the base is horizontal, that means, and this interior angle is 60 degrees, opposite interior angles are both going to be equal to each other, so this is also 60. Here's our perpendicular to the surface, and our incident angle is the angle the ray makes with that perpendicular. So if this is 60 degrees and the whole thing is 90, this has to be 30. Okay, so let's go ahead and solve Snell's equation, Snell's law, for the refracted ray inside, refracted angle inside the prism. Okay, so this is arc sine, same as the inverse sine. It's old language. Is times sine 30. The index of refraction of air is 1. I didn't bother to write 1 times sine 30 degrees. And this is going to be divided by the index of refraction of the material of the prism, 1.7, or about 17 degrees. You'll come up with a more exact answer as you do the work, okay? So now let's take a look. What is the incident angle at the second surface? Okay, so if this refracts in this direction, and this angle A here is about 17 degrees, well, we have a perpendicular here. Okay, that perpendicular is 90, so 17 plus what is equal to 90? That's 73 degrees. Okay, so angle B is 73 degrees. We know C is 60 degrees, so B plus C plus D has to equal 180. Solve for D and come up with 47 degrees. All right, so this angle here, D, is 47 degrees. Again, we have to draw a perpendicular at the second surface. Here, let me do that right. Let me see if I can do that real quick here. All right, going to draw a D, a little perpendicular. That's terrible. There we go. Let's try this. Still bad, but not terrible. Okay, so anyways, it's another perpendicular here. We want the incident angle, so if this is 47, D is 47 degrees. This one here must be 43 degrees. So I'll put a 4. Trying to draw with a mouse is terrible. Okay, 43 degrees. And an old mouse at that. Okay. 43 degrees right there. Okay, so just put that right there, 43 degrees. Okay, so we know that that angle there is 43 degrees. That's our incident angle. Once again, we're going to take Snell's law. We're going to solve it for theta, the angle of theta into the air. And if we do that, we get theta into the air. Okay, the angle, refracted angle into the air is arc sine of 1.7. That's the index of refraction of the material in the prism times sine of 43 degrees. Okay, divided by, well, we had to divide by the index of refraction of air, which is 1. And we get something that's undefined. Okay, because 1.7 times sine 43 degrees divided by 1 is larger than 1. That's outside the domain of the arc sine function. Okay, nothing refracts through. We get in total internal reflection. All right, let me change the color here. Maybe purple. Let's try purple. All right, and I'll do pencil here. Okay, what's going to happen is that ray is going to refract at just about the same angle. Remember, law of reflection, incoming angle, or excuse me, incident angle is equal to the reflected angle. This is also 43 degrees. Somehow purple writes better. Okay, so this is also 43 degrees. This ray is going to head, okay, way down here, and it's going to head, maybe more like, maybe like this, okay? It's going to head down to this direction here, and then we're going to have a refraction into the air from the bottom face. Okay, so now if you did the problem and you only had refraction at the back surface here and had it refracting out into the air, both of those rays out into the air, you're going to want to readdress that. Okay, and so write to me, tell me to delete the old argument, and then go ahead and you can redo that. Okay, so let's just go over here. Okay, so you have the red ray. Let's say the red ray is going to come out like this. We have the purple ray. It's going to come out like this. The angle between them is going to be that angle there. And you're going to have to use a little what you know about angles and triangles and geometry to figure that out. Okay, I want to end this and get that posted for you. Okay, so here we go.